So for example 3, let's go ahead and take a look at what's going on here. It's an inequality, and I hate negative leading coefficients with inequalities because I always forgot to flip the equal sign. So I trained myself to never have a negative leading coefficient. All of this stuff is moving over here to this side. The only thing that's going to be over here is 0. So this is going to be 0. I'm going to recopy this. Y'all, when this 2x or negative 2x squared goes over here, it's positive. Y'all remember this 10x moved also. So this 10x is negative 10x over here. So it's going to be negative 12x, because remember y'all had 2x's over there. And then recopy this 16. The 16 was already there. Don't change the sign. It was already there. All right, let's go ahead and start factoring. There's a GCF, y'all. Let's take out the 2 for sure. And then look, y'all, that 2 doesn't have a letter X by it. It really just goes away. We could divide both sides by 2. 0 divided by 2 would just be 2. So here's what we're dealing with. Remember, when you factor out a number, when you are solving, the number doesn't matter if it doesn't have a letter. And it didn't have a letter, so it went away. Okay, this is what we're factoring, guys. This is going to end up being x minus 4, x minus 2. So we know we have test points at x equals 4 and x equals 2. Let's draw the x-axis. Now remember, when I draw circles on these, they are part equal. So let's fill in those circles. All right, let's go ahead and do some test points here. I'm going to let x equal 0 on the low side. I'm going to let x equal 3. That's really my only choice in the middle. But on the high side, I'm going to choose 10 again. And again, at any part of your work, you can plug in stuff. I am choosing this line of my work. It just looks the easiest to me. You can choose whichever line of the inequality. You can also choose your own test points. So when I plug in 0, I'm going to get 0 is greater than or equal to 8. Of course, that does not make sense, so I know that this is false. Let's plug in a 3. So 0 is going to be greater than or equal to, this is going to be a 9. Negative 6 times 3 is negative 18 plus 8. So that is going to be negative 18 plus 8 is negative 10. 9 minus 10 is negative 1. Is 0 greater than or equal to negative 1? Yes, it is. This is true. Let's look at the 100. When I square the 10, minus 60 plus 8, and remember that needed to be less than or equal to 0. 100 minus 60 is 40 plus 8. That, of course, does not make sense. That is not a true number sentence, so I know that interval produces false answers. Speaking of interval, remember this middle portion is the only thing that's true. When the middle portion is true, and look, I'm using brackets, it's an and statement. So it's going to look like this. That's the answer for that. Do you have any questions on that? Y'all look. Let's go to number 4. Now number 4, I would put a star on our highlight because I know I just said set it equal to 0 and factor. I did, I said that. But on number 4, it's already factored, guys. If it's already factored, what do? You square root. Do this. Square root both sides. Don't forget plus minus. So when we square root both sides, this is what the next line looks, guys. Over here is x minus 4. It went away. The exponent went away. Don't forget to draw the plus minus, and that's perfect square. We all know that's 2. You're going to have two answers, guys. Let's add 4 to both sides. So x is going to be greater than 4 plus or minus 2. You know what that is? That is nothing. That is not finished. I've had so many kids turn in answers like that. No, 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 no. You can do 4 plus 2. You can do 4 minus 2. So x, we know it crosses the x-axis at 4 plus 2, which is 6. We know it crosses at 4 minus 2, which is 2. Let's draw the x-axis. I'm going to color in these dots because I'm going to remind myself it's part equal. Now, usually I say, this is why it's really important for you to highlight this. Remember, if it's already factored, you go straight to square rooting. When you plug in your test points, plug in from the beginning. Once you start drawing a square root symbol and doing the whole plus minus, then it's hard to gauge. Plug in test points here only at the original. All right, let's figure out what some test points are. Definitely x equals 0 over here. Between 2 and 6, I'm just going to do 4. It has to be. No, because it won't tell you the interval. Yeah, you'll probably just get 0. Higher than 6, y'all, I'm going to do x equals 14 because that's going to make it a 10 in there, which is going to be easy for me. Let me go back to the low side. We plugged in 0. That's going to be negative 4 squared, which is 16. Is 16 greater than or equal to 4? It is. So this is true. It's providing true answers. Let's plug in 4 here. 4 minus 4 is going to be 0. 0 squared is 0, and I get this. 0 is not greater than or equal to 4, so this is false. Most of the time they alternate. This better be true, but we should check it. We shouldn't just trust it. So when I plug in 14, I chose 14 to make that a 10 in there to make it easy for me. So I'm going to get 10 is greater than or equal to 4. It sure is. So your interval notation, remember, negative infinity always gets parentheses. It's negative infinity all the way up to the 2 with a bracket. Or, remember, it picks up again at the positive 6 to infinity. And that's the answer.